the coverage area is greater than what we have achieved, this will lead to no connection between them. Say for an example, your drone, your server, which is placed close to each other, these two communicate with each other. This will comes under machine-to-machine communication. This is one example, an example of IoT devices. Correct? Where we can use this drones. Especially in agriculture. Okay, so we cannot use these drones in militaries because it needs more range of distances. Okay, but when we have used this in agriculture, okay, so what this drone will do? It will monitor the soil moisture, or second part is your padding. Okay, so weather condition, everything we can monitor with the help of drones. But make sure that your server, data server and drone within a closer distance. Correct? If within a closer distance only it works. Okay, example, you are using Bluetooth. Okay, Bluetooth frequency 2.4 gigahertz. Now they have increased to 5 gigahertz. Correct? So if you are using your phone, you can switch over between 2.4 and also 5. An option is enabled there. When you are using this Wi-Fi also. Okay, so two frequency spectrum is provided when we are using this Wi-Fi, 2.4 and 5. But usually we will pick 2.4 only, because when we are going for 5, okay, it needs extreme bandwidth to allocate, right? But we don't want that kind of things. So we are normally surfing or just streaming the video only. So we need 2.4 to do that. Okay, then, and this is that 3 examples. Correct? So last class I have shown what is EMBB. So one example project you have to do. Okay, and second is MMTC, same as you have to do one use case project. And third is your URLC, one use case project. So this is your project. You have to choose on your own, or if you are not able to pick, I'll just give you the topics. You people go there and pick the topic you can do on it. Correct? Okay. So this is what we are going to do. Suppose if you want to do any hardware devices, we can go there in 5G lab, we can test. Right? But I told you last year that final year students have tested with this agriculture drone moisture. See, in 5G lab drone is available. Okay. AR/VR camera is available. Okay. Integrated camera will be available. Right? And you have a base station, you have a core network, okay, and user devices is available. Right? So with this, what we can do, you people have to take up. Okay. So I will tell you how the call flow or the data flow will be there. So with it, you can come with an idea. So what sort of things we can do with it. Okay. Fine. Okay. So now. So this one we have seen. Then this is what user plane and control plane. Yesterday we have discussed, right, last class. That is CUPS. Right, a separation between user plane and data plane. You should know what is user plane, what is data plane. Right. So here this is UE and this is your RAN. What is RAN? Radio access. So what is that? Radio access network. The radio signal which is accessing the network between UEs and RAN to core network. Right? So till now we have known what is core network. What is core network? These are all the parts of core network. Till now you know what is UE, what is RAN. So RAN is nothing but your base station. Last class I have told you. Correct? this is your user equipment, your mobile phone, and this is your base station. Correct? This base station, your user equipment, which is connected to your base station via RAN, that is radio signal. Correct? Till that you know. Correct? Now we are going to access the core network. This is your core network. This is what we are going to see detailing about the upcoming topics. Correct? So what is AOSF? What is the function of AOSF, PCF, UDM, AMF, SMF? This whole thing we are going to see detailing in the next upcoming slides. So this is what the core architecture of 5G. Likewise, we are studying for 2G. Correct? So what is there in the 2G? 2G, MSC, Mobile Switching Center, HLR, VLR. So only 3 components and one more AUC, authentication. So 4 components which is present in 2G architecture. But now you can see in 5G architecture how many components is added over here. 1, 2, 3, 4, 5 and 6, 7. So totally 7 to 8 components which is added in the 5G architecture. So this is the modified architecture. Yeah, when you are going for 6G, what they will do is simply they will have the same architecture and they will add any extra few blocks over here for better performance. Okay, so 6G, between 5G and 6G, what is the main drawback? Between 5G and 6G. One is data rate, we need it. Second is latency, we have to reduce. Correct? So based on that, they will develop one component and they will place it in the core architecture. So that will become a 6G architecture. Simple. Okay. So when you are going for 6G architecture, they won't replace all the components which is present inside. They will add an extra feature block which is in the core architecture. So that will come to the 6G architecture. Right? Okay. Right. So I told you, right? So you have a control plane and data plane. Earlier in 4G, both control plane and data plane which is present inside this RAN. Okay, so inside this RAN means you have a base station tower is there, right? So under that, at the bottom, they will have this what? Control plane and data plane. Together constitute, you have a black box will be there. So that black box will perform both control plane and data plane. So that control plane and data plane will be given to the core architecture. But in 5G, they have split into core architecture, control plane and also data plane separate. So why we are splitting here? What is the purpose of you splitting here? One is, these are all the control plane functions. What it will do, it will used for control the signals or control the traffic or initiate the call. Right? So entire data call management function which is done in this control plane. Only call management, initiation or any traffic flow signals will be done in this. But in case of user plane, this is your user plane. This user plane which is simply used to transfer the data between your RAN and your external network. That means you want to transfer voice call means simply divert your call and it will be given to the user plane. This user plane simply transfer to the external network. Same as data. Right? When you know the destination user, it simply route the traffic which is sent to the user data. But in case if we have 100 subscribers, okay, but we need more number to accommodate. So 100 subscribers is approaching this core network. Okay, so what they will do is, but we have only 50 to accommodate. So 100 subscribers approaching the core network. Okay, but we have only 50 places to accommodate. So what it will do, this control plane function will comes into act. So this control plane function, based on the availability, it will accommodate in FIFO. That is first in, first out. Okay, suppose if 50 is available, okay, but only 10 users is there they are approaching the core network. 50 slots are available, 10 users approaching means. So they don't want to send to the control plane. They can simply transfer directly via user plane. Because there is no such traffic will be there, because abundant resources is available. Correct? So in that case, it will simply transfer the data from user plane to the external network. Able to understand? But in case of traffic, so only 50 is available, but 100 subscribers is there means automatically it goes to the control plane. So entire traffic control will be done in this. I'll tell you which block, what is the function of each and every block. But if the abundant source is available, there is no need to go to the control plane. It simply diverts to the user plane. So user plane receive and simply forward to the external. So that is the purpose of using control plane and user plane separately here. But in case of 4G, we don't have this kind of options. So each and every time it will go to the both control plane and also user plane. It will take time to reach, and from there it will go to the external. Okay, this one extra feature which is added in, right? Okay, yeah. Okay. Right. So this is what multi-access connectivity. Okay. So last class itself we have seen. Okay. So before going to that, you should know what is macro cell base station, femto cell base station. Other things I think you people have known. Wi-Fi access point. Okay. And macro cell base station, femto cell. So you have different types of small base station. What is the different types of small base station? Instead of having a large base station, we need to cover more area, right? So if a large base station is there, see, listen, this is your hexagonal cell. Okay. What is hexagon? 6 edges. 1, 2, 3, 4, 5, 6. Okay. So each and every geographical area which is divided into different hexagonal cells. Say for an example, this place, this Kotheri, okay, will be considered as one hexagonal cell. Not Kotheri, SRM campus from hospital to your main campus. Okay, so which will be considered as one hexagonal cell. Why they are taking any hexagonal cell? Why don't they take as a circle? See, this is nothing but the coverage area. So better understand. Okay, the hexagonal shell is your coverage area. Why they don't go for circles? Yes, listen. This is SRM from main campus to medical. Okay. Next, from main campus to Maraimalai Nagar. Okay, the coverage area. Like this. From Maraimalai Nagar to the next spot is your, I think, Singaperumal Koil. Yeah, this is your third spot. Correct? So, when we take like this, okay, so each and every hexagonal cell will have one base station here. Okay, for coverage. Right. Now, what happened is, when it comes to this, by using this base station, okay, you can get a wider range, but the data rate must be very lesser because you have only one large base station or one large tower to cover the whole entire area. Okay, so this is called as macro cell. Correct. Next we are going to that femtocell, picocell, microcell. What is micro? 10 power minus or minus 6. Pico, femto, right there. So that means, what about your cell size? Lesser or higher when we are using this as a cell? Less, right? So instead of having a larger base station, we will be having a smaller base station for a particular coverage area. Say for an example, I told you right, from this medical to main campus, we will have 5 smaller femtocells will be there for giving an entire coverage. That means this is not a tower. I'm just giving as a tower. This is simply an antenna. Okay, it will be like this. It will be placed in each and every corner of the building. Okay, in order to provide a 5G coverage. Okay, so earlier they will have a base station like a tower, but nowadays they will be placing in a smaller antenna. So if you want to travel from this medical to your main campus, you can see 5 access point like this. So this is nothing but your antenna. This is not an antenna. Like this, your antenna will be placed in each and every building. In order that, okay, your coverage will be good and also your data rate will be good and your latency will be less. Right? So that they are moving for this femtocell base station and microcell and one more picocell will be used in 5G. But in case of 4G, you don't have that kind of facility. Right? So what will happen is this microcell, femtocell and picocell will be used for only shorter coverage. Okay, yeah? Right? Because the cell size is smaller. Right? If you move out of the cell, it will go to the another cell. Correct? So that will be taking care. Simply see, if you are moving from one base station to another base station, okay, this technique we can call it as handover technique. Okay, one base station to other base station, nothing but, so you are sitting in a car, you are moving at a faster rate, your car will be accessing this tower. At some point, you are moving away from this tower, automatically this second tower will be accessed and this will be goes off. Okay, likewise the tower is placed. But nowadays, so far, this tower can cover up to 10 kilometers. One tower can cover up to 10 kilometers. So till that, your car is accessing that first tower. Right? Then we are moving from nether to next base station. It will be automatically switch over. Right? Same as suppose if you are driving in a car, okay, at probably in Madurandanam, when they are crossing Madurandanam, when you are using FM, you can see a mix of signals will be there, FM signals. Like there is an improper handoff which is taken place during that time. So this is proper handoff. Improper handoff means both the signal gets interfered with each other. That means 93.5 Mansoorian FM something and 98.3 some Radio Mirchi, they are going to get interfere at each other at some point. So that point is when we are crossing from that base station to another base station. right? You have to understand. So that is, you can try, okay? So when you are going via car, when you are crossing around Mayor Morotur and Madurai, right? So this towards the south, you can experience this, right? Poor quality of signal during that time. Right? Okay. Now comes to the main parts. So far we have known, okay, 5G enablers, edge to edge connectivity. Second number, control plane user plane separation, multi-access connectivity, mobile edge network, that is edge computing. Okay, right. So what are the three use cases used? EMBB. See, use cases means these three. Okay, EMBB, MMTC, URLLC. Fine, right? Now we move to the most important part, that is standalone, non-standalone architecture. What's the time? So we'll finish this. Right. So before going to that, you know what is the base station of 4G network, what name we can call it as, what is the core network, what is the base station of 4G, what is the base station of 5G, what is the core network of 4G, what is the core network of 5G, what is the RAN of 4G, what is the RAN of 5G. Correct? With that only we can proceed with that. Right? That terminology we have studied, right? What is the base station of 4G? E node B, good. 5G? G node B, correct. What is that is base station? What is the RAN of 4G? Utron. 4.5G? E Utron, correct? 5G? 5G? RAN, right. And what is 4.5G base station? LTE E node B. Correct? You should know the terminology. Okay. Base station part over. Then core network. So what is the core network of 4G? EPC, Evolved Packet Core. Right? What is the core network of 5G? 5G NAT. So we know some basic terminologies of this, right? Then we have seen what is user plane, what is data plane. Correct? So what is user plane? User plane is nothing but simply transferring a data or voice call from user to the destination. Right? What is control plane? Three things I told you. The control plane will controls the entire core network. Second is traffic management, call initialization. Call initialization. Right? So these three are the main things which is related to control plane. Now you know the terminologies. Now you know the functions of what is control plane, user plane. Together we are going to see what is standalone network, what is non-standalone network. Right? So far we are using non-standalone network only. Right? But the only one operator they are providing standalone is your Jio. So Jio have that kind of facilities they have provided for this 5G network. Okay, so I'll give you a real-time example. Okay, you are using 5G phone, correct? How many of them is using Jio here? Yes, only one. 2, 3, 4, 5. Airtel. Oh, Airtel is more. Vodafone Idea. BSNL. They're using BSNL. Good. BSNL.
BSNL and
BSNL and Jio. So dual SIM. How many of them have seen in Airtel? You have a 5G signal, correct? The signal will be placed at the right topmost corner. But sometimes it is changed to 4G. Yes or no? Correct. So that is your non-standalone network. That you can experience in Airtel only. Airtel, Vodafone, BSNL, they have not moved into 5G. So only these two. But in Jio, we cannot see that 5G signal will be changed to 4G. If 5G signal is there, it will show only 5G. If it is not available, automatically your signal goes off. That's it. But there is no changeover takes place from 5G to 4G. Correct? I think you people have experienced. Correct? So that is what 5G standalone architecture. That is what 5G non-standalone architecture. Simply 5G architecture, 5G standalone architecture is nothing but you have a dedicated core 5G network, you have a dedicated core 5G base station and your user experience. But in case of non-standalone architecture, there is no dedicated 5G base station, there is no dedicated 5G core network. That means with the help of 4G, your 5G is enabled. Like physical experience, I can tell you, by getting a cable from 4G, we are giving to 5G. Right? The device which is working on 4G will be getting a cable, extra cable, and giving for 5G enabled components. Right? But this only standalone architecture, we have a 5G components, only 5G cable that will enable your 5G signal. Right? Okay. So that's what this Jio is moving a far better from all these operators. Now, if the 6G is proposed, automatically they will go for 6G standalone architecture. That means they are using entire component which is only related to 6G. Right? Okay. Right. That's what. We'll see. See which are all the core components here. Now you tell me what is this EPC? Core of 4G. 5GC, core of 5G. eNote B,
4G.
What 4G?
4.5.
Right.
Base station.
Base station. And this eLTE, eNote B, 4.5, 4.5G, and this is eLTE is 4.5G base station, eNote B is 4G base station. Correct? Then gNote B, you can see a pictorial representation of this. This implies what? A mixing up of 4G and 5G network, which is called as non-standalone architecture. So that is what the arrow mark which is used. Okay, so here we are going to see what is non-standalone architecture simply. Because if it is a standalone architecture, you can get that signal directly from 5G base station to the 5G core. But the real part is you cannot get the direct signal from 5G to 5G. Right? Only Jio only have introduced that too a year before. Okay, but still this Airtel is holding this 4G to 5G architecture. That is your non-standalone architecture. So we are going to study this, discuss deeply about this 4G to 5G, that is non-standalone. Right? Okay. Clear? Hopefully it is clear. earlier, now it is deployed NSA. Okay, earlier the designer doesn't know what is the possibility of connecting these to make a non-standalone architecture. That means from 4G to 5G. Right, part of 4G architecture is there, then part of 5G architecture is there. We are connecting both, which is non-NSA. Right, but earlier they don't have that much of idea. They have done with some permutation and combination connection. Then they finally fixed, okay, this option is good for NSA. Okay, understand? So they have tried 3 options there. Then finally they will stick with one option, and now they are implemented with that option. Right, okay. What is the 3 options? Option 1 is we are connecting directly from EPC to eNote B. That means just imagine eNote B is your 4G base station and your EPC is your 4G core. Now this option 1 is what? It's purely 4G because we are using 4G base station and 4G core network. So the access is only for 4G. There is no such 5G is happening in this option 1. Right. Second option. This G-Note B to 5G. This option 2 is your, it's purely 5G, and this is also, see, this is also standalone architecture and this is also standalone architecture. Why? Dedicated 4G base station, 4G core network, so it is standalone. And here dedicated 5G and 5G core network, it is standalone. Now come to this part. This is ELTE, okay, and this is eNote B, right? Now, and what is this? 5G core network, and this is your, you can see this base station is accessing 5G core network, also your 4G core network. Correct? So now the problem comes into this part. Correct? Okay, so this base station is accessing both 5G and also 4G. Right? Why? Because they are going for NSAs in order to deploy a different 5G base station and different 5G core network. Okay, it will be much complex and also it is costlier. Okay, because we have to deploy the 5G components, so that they are taking help from the 4G components. Right? Anyhow, if you move to 6G means at that part what will happen is Airtel will move from non-standalone to standalone, and 5G, this Jio will move from this 5G standalone to 6G NSA. They won't go directly to 6G SA. Correct? Because they have to deploy again all the components. So they will move from this to 6G NSA, and they will move from totally 5G SA. Like that? Okay. Right. So with this, they have deployed 7 possible combinations. Okay. So in this combinations, you have to tell which is good. So which combination will take and will implement for non-standalone architecture. Okay. So before going to that, this is your option 1. This we have seen. Correct. So this is 4G non-standalone. Standalone architecture. This is option 2. This is 5G standalone architecture. This is non-standalone architecture. Correct? Okay. When it comes to here, they have deployed 3 options here: EPC, eNote B, G-Note B. Correct? So your core network is what? 4G. Your base station is, one is 4G, another one is 5G. Correct? Your option 3. Okay. Okay. So your entire core network is 4G, and the base station is 4G, and the base station is 5G. That means with that 4G network, that is 4G core network, the base station we are going to access is both 4G and also 5G. And comes to this part, this is your 5G core architecture. Your base station is 5G, 4G, 4.5G. Correct? And next is 5G core architecture, LTE, that is all 4.5G, 4G and 5G. Okay, so now they deployed a better option, which is option 3. Why? They are implementing this option 3 instead of having option 4 and option 7. Why? See this picture and tell me. Instead of deploying option 4 and option 7, they are deploying this option 3. They are taking this option 3, okay, and they are going to deploy this as a non-standalone architecture. Like instead of going for this core 5G core architecture, okay, they have stick with that 4G core itself. But they need a RAN as 5G RAN, because in order to provide a higher data rate, they are going for 5G. Correct? When we deploy this 5G core, so what happens is the entire architecture will become 5G. Because based on the 5G architecture or 5G core network only, everything will be deployed. Okay, so that is not possible as of now. Now it is possible like Jio. Earlier, if you deploy this 5G core, okay, automatically you will be switching over to the 5G standalone network, right? But with the help of 4G core network, we can access the 5G. That is the option 3. Here, the entire core network is your 5G. The entire core network is 5G means automatically it will go to SA. Correct? So what I said, we have to get a cable from the 4G and we are going to give the 5G. Correct? So get a cable from 4G means from 4G architecture. That is 4G core. Right? So that's why they deployed option 3 as a good option for NSA. Able to understand? Because this 5G core architecture at the time it is under research. Now Jio have deployed, but earlier. Right? Now what happened is, even though they have choose this option, okay, but there need to be modified few things in order to get a non-standalone architecture. Right? So listen, first you have to identify which is NSA, which is SA. Correct? Once you identify which is NSA and SA, the designer have gone for few multiple permutation and combinations, which works well. That is these options. Right? The designer means who's doing research on this. Okay. Then once they found out this option 3 is good, okay, they take these three, the option 3, and they go for the modification in option 3. Right? That I showed you. Now you see, this is option 1, correct? Okay. So what is the modification in the option 1? Becomes option 3. Huh? What is the modification has done in this? From option 1 to option 3. Simply adding 5G base station. Correct? Option 1 is entirely 4G network. Correct? How this 4G network is changed to NSA 5G network, they are showing you. Right? So option 1, see, this is your option 1. This is your option 1. Correct? This option 1 is changed to this option 3. How this happened, they have given here. Are you able to understand? Right. This is option. Right. Now, this is for 4G with 5G. Right. But what happened is, after 5 years, 4.5G is evolved, LTE. Correct. Then they have deployed this E node B, ELTE along with this G node B and EX. Now what happened? Your core is 4G, and your accessing base station is 4G, 4.5G, and 5G. Now itself, you think of yourself, okay, if a call comes, okay, it will be diverted to 4G. If you need more data rate, it will be diverted to 5G, because we are using two base stations. Two base station means just don't think that you have two towers. Okay, in that tower at the bottom you have a baseband unit. In that baseband unit, your 4G will be deployed, your 4.5G and your 5G will be deployed. Based on the customer needs, it will be different. Right now, okay. Now, next from this option 3, how this is converted to option 4. How this is converted? See, this is, example, you have an EPC, E node B and G node B is there, correct? This is your primary node, that is master node, and this is your secondary node, that is your slave node. That means, if G node B wants to access this core architecture, this 4G core, they have to pass via E node B and they have to access it. They cannot bypass directly from here to here. Are you able to understand? Right? I'll show this picture that it is. Now listen. So which option they have chosen? Which option they have chosen here? Option 3, right? After choosing this option 3, they have done some modification and they have named it as 3A, 3X. What modification they have done? But as you have to know, your core is your 4G and you have the master node is your 4G base station and your secondary node is your 5G base station. Now see, EPC, E node B, G node B, user equipment. Just imagine, okay, your user equipment is here. Your user equipment is here. Okay, yeah. This is your base station, right? And here it is your core network, right? Your core network is 4G, right? From user equipment, the signal will goes. Okay, so what type of RAN we are using here? RAN, because RAN, which is used to access between your user equipment to the base station, right? So which type of RAN? U-TRAN. And the base station here is, just imagine you have a box at the bottom side, so which is deployed with 4G, 5G. So 4G and 5G. Then the access will be given to 4G, 4G. So this is your real-time scenario. Just imagine like this, how this is connected. Able to understand? Right? Okay. Now, this is your user equipment, E node B, G node B, EPC. Now see the first statement. 4G E node B provides control plane connectivity to the core network. Now the control plane and data plane comes into act. I told you what is control plane, what is data plane, right? So what is control plane? The name itself specifies control, means it controls the entire network. How it will control? Based on any traffic is there, it will find an alternate route. Okay, so all type of control options will be how the call is initiated, that all things will come under control plane. And user plane is nothing but simply used to transfer the data between your source and the destination. Right? So source and the destination means nothing but your user equipment to the external network. Right? Okay. Now, here 4G E node B act as master node and 5G E node B act as a secondary node. I told you, right? So 4G E node B will act as a master and 5G G node B will act as a secondary node. Right? So all user plane data in option 3 is tunneled through 4G E node B. What is it meaning? all user plane data in option 3 is tunneled through 4G eNodeP. So here you have two planes, okay, between each transfer. Like say for an example, from user equipment to base station. So this RAN contains control plane data and user plane data. Data. Okay. So what is this control plane here is mentioned as C. User plane mentioned here as U. And S1 is nothing but the interface. What is interface? Normally which is an air wireless medium. Okay, so here it is air interface which is used to connect between EPC and eNode. So interface is nothing but connection which is used to connect between those two. Correct? So now S1C is nothing but your S1 interface of control plane, S1 interface of user plane. Right? So what here? All user plane data in option 3 is tunneled through 4G eNodeP. So what will happen? This GNOP, suppose this 5G base station wants to connect to EPC, means it cannot connect directly because this is the secondary node. So each and every time it has to pass through this eNodeP, and this eNodeP will connect to EPC. Correct? That's what all user plane data in option 3 is tunneled through 4G eNodeP. So from this it will goes to 4G, from this 4G it will goes to the 4G code. Right? So here the connection between eNodeP and GNodeP interface is X2U and X2C. Right? Like one real time example. I am standing near the tower. Okay, that tower, that base station is deployed in both 4G and 5G. Right? I want to use 5G data. Correct? I want to use 5G data. That means I want to stream video, live stream. Okay. So how this will works is, when I connect this data will goes to the 4G base. Sorry, this will goes to the 4G base station. From the 4G base station, it reaches the 4G. Correct? So the tunneling is happened from the 4G base station to the 4G. It will, even though I am standing near the 5G network. Correct? That is NSA. Are you able to understand? But now Geo, when I am standing near the 5G network, if I want to use the 5G access, means it will directly from 5G base station connected to the 5G core. Right? So that is NSA, this is SA. Able to understand? Okay. Now, this data is split by eNode PDCP layer. I will tell you what is PDCP layer. Between eNodeP and GNodeP. The data allocated to GNodeP is forwarded across X2 interface. Okay, so that is what. If you want to access this EPC core, we cannot directly approach this. Okay, so what we have to do? We have to go via eNodeP, and from this eNodeP it goes to EPC. Okay, but this is a drawback. Correct? Every time we cannot go via 4G base station reaches that core network. Correct? So drawback is eNodeP needs advanced hardware to support high data rates of 5G, as it is designed to support 4G air interface. Able to understand? I am standing near 5G. I want to access the core network, means it will go to the 4G network, 4G base station. From the 4G base station it reaches the core. But that 4G is not enabled with 5G devices, 4G base station. Correct? If you want 5G, means you have to get directly 5G. If you go via 4G, it will access through 4G speed only, correct? Because 4G is equipped with 4G data only, 4G components, right? So that is the drawback. So in order to overcome this, they will go for the second option. Okay, this is option 3A. Now you tell me what changes I have done here. The first 2 points is same. 4G provides control plane connectivity towards the core network. 4G acts as a master node and acts as a secondary node. The option 3A resolves drawback associated with option 3 by providing S1U interface between EPC and G-Node. Now you tell me what happened here. Instead of going via E-Node B to EPC, okay, they are placing a tunnel which is connected directly to EPC, but there we can use only user data only. Okay, but your control plane which is connected not directly to EPC, that is via 4G base station to the EPC. Right, I'll tell you what is advantage. Still, E-Node B decides which EPS bearer to be transmitted to E-Node B or G-Node B, but the traffic split happens at EPC. Correct? It does not support transfer of data over X2 interface. Now, just imagine what they are giving here, that X2 interface data is here, right? Previous slide, option 3, 3A, option 3, okay. So here, listen, because if you understand, you can write it on your own. Just draw the picture and you can explain on your own. Right? See, earlier you have what you have here in option 3. You have X2 user, correct? Right? But now what happened? This will be replaced to this. Right? The interface which connects between E-Node B, G-Node B is X2. The interface which connects between base station to core network is S1. Right? Instead of going via E-Node B to reach the EPC, I told you, right, I need links. One is connected via 5G, one is connected via 4G. So that is what installed here. You can see here. Your voice is transferred where? From G-Node B to E-Node B. E-Node B will reach as EPC. Your data, your internet will be transferred directly from G-Node B to EPC via S1U. Your voice is transferred from G-Node B to E-Node B X2U. Correct? So that I can have two transmission of data within a single time. Correct? Instead of sending both voice and data over this channel, okay, and transferring the data via 4G, transferring the voice via 4G to this core network and transferring the data directly to the core network. For this we need this kind of option 3x. Able to understand? Right? So that's what. If coverage from G-Node B becomes weak, then the G-Node B can dynamically forward data across X2 interface towards the E-Node B. Correct? So which is weak? Say for an example, this is weak. If LTE is weak, okay, because this user equipment which is moving towards, which is closer to G-Node B, if this LTE is weak, what will happen? How the data transfer takes place? Now comes the real part. Okay, this is weak, man. How can you say this is weak? How can you say this is weak? This LTE is weak now. That means your user is closer to G-Node B. Right? This LTE is weak. How the data is transferred now? From 3A, from 3, option 3, just imagine. Correct. Which base station? 5G base station to core. So for this case, in this case of scenario, if this is moved to this, your 5G signal is weak, your 4G signal is good. How your data will be transferred?
That's via
That's what. It will transfer via E node B, the data will be transferred via E node B. From E node B, it will reach the core network. See, that is what they have explained here. If 5G is good now, it will send directly to them. If 5G is weak now, it will send via 4G, and from 4G it reaches the core network. So this option is called option 3X finally. That is what X2 interface is having. Right? So what is the interface between G node B and E node B? X2. From base station to core network? S1. How many planes is used to transfer your data? Data plane, control plane. Okay, so data plane is used to transfer only your data or voice. Control plane is used to control the traffic. Correct? If you know all these terminologies, you can write blah 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 with this picture. Correct? Okay, fine. For you to understand this, this is your non-standalone architecture. Correct? So that's what you can take your phone. If you are using Airtel, if you go somewhere else, automatically, if your signal 5G is weak, means automatically change to 4G. Correct? So that works on this technology, this technique. Correct? Like if you go some other place, if you have 5G means it won't change to 4G because Jio is your standalone architecture. And that too now only they have improved, but earlier this thing is there in Jio also. Right? Okay. Thank you. So we will start. Any other? 22.